Hello students, welcome to lecture 10 of polynomials. In last lecture we had done division of polynomials. We'll just recall it. That was nothing but a polynomial p of x. If it is divided a polynomial g of x, then this is the form of the division of a polynomial. Correct? Rx is the remainder and q of x is the quotient. Now we will do the remainder theorem. That is, what does the statement tells us? That let p of x be any polynomial whose degree is greater than or equal to 1. Okay, of degree greater than equal to 1, and there is some number. We can say alpha is a number which we don't know, so it is a variable. We write it as alpha. Be any real number. As we don't know, we just write alpha, that is a variable. Okay, then what will happen? Then when p of x, this p of x is divided by x minus alpha. Now see, the form is x minus alpha. Here g of x it is given, but here they are giving x minus alpha. Then what will be the remainder? Then the remainder is p of alpha. The meaning of this statement, see, if in a very simple language I write that this is p of x, a polynomial, it is divided by x minus alpha, then the quotient is q of x and the remainder is r of x, but that remainder is what? P of alpha. So we have to prove this. We will prove that the remainder is, so what we will prove? We will prove that p of alpha is the remainder of the given polynomial r of x. That is r of x. And p of alpha is the remainder when p of x is divided by x minus alpha. Now it is very simple that if we do any kind of division, okay, suppose I divide 4 by 2, then I will get 0 as the remainder. Here remainder is 0. Or if I divide 5 by 2, then the remainder is 1. Yes, that means either the remainder is 0 or remainder is not equal to 0. That means it is a constant. Correct? So, to prove this theorem, there are case 1 and 2. Which are 2? They are either the remainder is 0 or the remainder is not equal to 0. Now let us take first one, that if r of x is equal to 0. Okay, then what will happen? Then first let me write the equation that p of x is nothing but x minus alpha into q of x plus r of x. We are taking the condition r of x is equal to 0. So this statement will come as this. Okay, we'll put r of x is 0. So we will get x minus alpha into q of x. Now I can say that this x minus alpha is nothing but a linear equation. So I can write that x minus alpha is equal to 0. Then x will be equal to alpha. So I can put x is equal to alpha here in 1. Then what will we get? P of alpha is equal to alpha minus alpha into q of x, which is equal to 0. So first condition is done, that the remainder can be 0 or not equal to 0. So I can say that P of alpha is the remainder because we are getting it as 0. In second condition, if I take, that is case 2, that is r of x is not equal to 0. That means it is some constant. That means it is a number. You know, in division, either the remainder is 0 or not equal to 0. So, what will we do for the same? See, let me write the equation. P of x is equal to x minus alpha into q of x plus r of x. Now see, here if I see x minus alpha is the linear polynomial, correct? Why? Because the degree of this variable is 1. Okay, so degree of x minus alpha is 1. Now, in the division of polynomial, we have done that if x minus alpha is a linear polynomial, then the degree of r of x is 0. Okay, the degree is 0, so it will be a constant, right? Understood? That is, let r of x be equal to r, because the degree of the remainder will be 0. What is r of x here? R of x is nothing but the remainder. Okay. Now its degree is 0. That is, if there is any, so it will be the constant. Like if there is any constant r, its degree is x raised to 0. So it will be a constant. Got it? So if r is not equal to 0, we can say that the remainder is a constant, as its degree will be 0, because the divisor is a linear polynomial. Okay. Now, what are we going to do? We will keep, first we will put r of x is equal to r. Okay. In the below equation, that is, p of x is equal to x minus alpha into q of x plus r of x, that is equal to x minus alpha into q of x plus r. Now we know that x minus alpha is equal to 0. We can say it is a linear equation. X is equal to alpha. Okay, this is one thing. Now put x is equal to alpha in 2. So we get, what do we get? P of alpha is equal to alpha minus alpha into q of alpha plus r. This is equal to 0 plus r. So P of alpha is r, which is a constant and which is called a remainder also. Hence we have proved that P of alpha is the remainder when P of x is divided by x minus alpha. Got it? Got it what we have said? Correct? See, I will teach it again. I'll explain you again. What I have done is that this is the remainder theorem, that P of x is a polynomial whose degree is greater than or equal to 1. Now there is a number by which it is divided. Okay, that is a alpha. So we will write divided by x minus alpha. Now this is the form which I want to explain you. That if P of x is divided by x minus alpha, then the quotient is q of x and the remainder is r of x. We have to prove that this r of x is nothing but P of alpha. Okay, that means when I put the value alpha in the given polynomial in place of the given variable, the remainder should be P of alpha. Okay, now see. So for this we need two remainders. One should be equal to 0 and another is a constant that is not equal to 0 here. This is nothing but constant, and here r of x is not equal to 0. Got it? We know that whenever we do division, either the remainder is 0 or remainder is a constant. Correct? Now the same thing we have done in the case 1 and case 2. That is, if I take r of x is equal to 0, or r of x is not equal to 0. Let me take r of x is equal to 0. Then here we have got p of x is equal to x minus alpha into qx, correct? Now we can say that x minus alpha is a linear equation. So let us put it equal to 0. Then we will get x equal to alpha, because alpha will go on the right hand side, correct? So this will be what? See, if x minus alpha is equal to 0, x will be 0 plus alpha. So x is equal to alpha. Got it? Like this. So I'll put x is equal to alpha in the above equation. We'll get 0. So it is a remainder. And the next condition is r of x is not equal to 0. Then it will be a constant. Now we know that x minus alpha is a linear polynomial, hence its degree is 1. And according to the division of a polynomial, if this, that is if g of x is the degree, is having degree 1, then the remainder will be having degree of 0. That is, it will be a constant. Okay. See, let me write this properly. That is, let r of x is equal to r, which is a constant, a number. Here r of x is remainder, its degree is 0. That is, r into x raised to 0 is equal to r, that is constant. Put r of x is equal to r in the below equation. Then you will get this. Okay, the same thing. This is nothing but linear equation. And putting x is equal to alpha, we will get p of alpha is equal to r, which is equal to constant, which is equal to the remainder, and hence proved. Okay, so thank you very much. I hope you will understand. Go through this lecture again and again, and then you will be able to understand the remainder theorem. Now we will do sums on it, so it will be much more clearer. Okay. So I end my lecture here. Thank you very much.